For the purpose of the discussion, we are using a simple data set here, excerpted from Andrew Jacquet's book on security metrics. This is a table of application defects data set that was collected during a recent risk analysis on its in-house developed application. The goal is to analyze the level of security of all assessed applications. Each row is a record that embodies a core security event or concept, such as a security defect, privacy violation, open port, or defected virus. The core event we are recording here is an application defect with the following attributes: name of application, department of business owner, name of defect, exploitability, index score, for example, based on CVSS, a cross-industry proposed standard that provides a consistent method of scoring the seriousness of computer security vulnerabilities. The higher the index number, the easier it can be exploited. Impact, if exploited, which is an index score based on asset value. Business adjusted risk is an index score, is a product of exploitability and impact. Cost to remediate, estimated engineering hours. So this table shows a sample data set containing 27 records from a single quarter, first quarter from year 2005. First, let's see the grouping and aggregation example. Non-numerical attributes are aggregated by counting them. For instance, applications, owners, and defects. We can also group them by department. This would have produced 3 sets of aggregate results, one for each group. For numeric valued attributes, we can generate the summary statistics numbers such as mean, median, standard deviation, and also box plot diagrams. For small data set, an Excel pivot table could work fine. For a larger data set, simple formulas will not do. Consider most sophisticated tools such as R, Python, SAS, SPSS, or business analysis tool combined with a relational database storage. Time series analysis, quartile analysis, and correlation analysis rely heavily on grouping and aggregation techniques. Time series analysis refers to the technique of attempting to understand how a set of data behave over time. More specifically, a time series contains a series of observations for particular attributes measured at regular intervals. Time series are generally grouped and aggregated by a desired analysis interval, such as hours, days, weekly, or monthly, depending on the data frequency and the granularity of the analysis efforts. The analysis interval should be sufficiently precise that it lends insight, but not so much detail that overwhelms the reader. A typical analysis interval for most security metrics worth measuring is monthly or quarterly intervals. First, grouping and aggregating all records within the desired interval of time. Here, we use monthly interval in this example. After aggregation, we can sort the result set by date, generally in ascending order, so that earlier entries appear first. Key observations from this time series analysis. The number of security defects declined from 14 to 5, suggesting application security improved overall during that period. Although the overall number of defects decreased, those defects in later periods were of higher impact and were slightly easier to exploit. The amount of engineering time required to fix defects increased over time, from 14.9 to 28.2, as did the standard deviation of the estimates. This in turn suggests that easy-to-fix problems were likely fixed early. Estimates for the remaining harder problems have become more consistent over time. Time series analysis is an essential tool in the security analyst's bag of tricks. It provides the foundation for other types of analysis. When combined with cross-sectional analysis and quartile analysis, it provides the basis for benchmarking. If time series analysis attempts to understand how an attribute varies over time, cross-sectional analysis asks how the data vary over a cross-section of comparable observations. If we slice a set of records by a particular attribute, what happens to that other attributes? Cross-sectional analysis involves 3 steps. First, the analyst selects an attribute to use for creating the cross-section. That is an attribute to slice with. Typically, textual attributes such as a department, industry, or categories make good cross-sectional attributes. After selecting a suitable attribute, the analyst groups and aggregates the data. Finally, the real fun begins, analyzing the results. For instance, suppose we want to analyze the performance of each department using the owner attribute as the cross-sectional attribute. Then conduct a suitable grouping and aggregating strategy for the cross-series analysis. 2 summary statistics. Mean defect per application. Mean bar per application. Both of these metrics help us understand how well each department writes code. There are several key observations. Operations, the application group, appears to be worst off based on the number of defects per application, which is 11, and the risk carried by each bar score of 128. Compare this to sales, the organization, whose application contain just 3 on average, and the bar score 80% lower, which is 24.5. In addition to having fewer defects per application overall, sales organization defects tended to be consistently less serious. Note how the sales department's mean bar per effect is 8.2, was considerably less than those of operations, which is 11.6, and IT, which is 13.4, and had a lower standard deviation, 2.5 versus 6.1 and 8.9. Although IT sits between operations and sales with respect to average defects and bar scores, its defects tended to require the least amount of engineering time to fix, 8 hours compared to 29.8 and 11 hours. This suggests that IT has more quick-hit opportunities and may have more potential to improve its score in the future relative to its peers. Trivial though this example may seem, it should demonstrate to you that cross-sectional techniques provide a powerful way to compare security effectiveness by organization, security topic, or other attributes. Suppose the sample dataset contained an attribute that classified each security defect, such as authentication, encryption, and user input validation. A cross-sectional analysis might compare the incidence rate by department for each type of defect. Managers could use knowledge of this trouble spot to better target developer training. Department could also compare notes and share knowledge of best practices.